It says 8 persons, Abhil, Barun, Christ, Deepu, Ezhil, Filphs, Guna and Harish are seated in a row facing north. Their positions are numbered 1 to 8 from left to right. Each of them has some red and some green marbles ranging from 1 to 8 in number. No two persons have the same number of same colored marbles or same number of total marbles. They are standing from left to right in the ascending order of the total number of marbles they have. Right? And then clues have been given to us. Filphs is seated at the extreme right end of the row. The number of marbles with Abhil and Christ is equal to the number of marbles with Filphs. Number of green marbles with Filphs is equal to the total number of marbles with Abhil, and so on. So I think the crux of the question is that there are 8 persons, A, B, C, D, E, F, G and H, let's say, who are seated in a row facing north. Their positions are numbered 1 to 8 from left to right. Each of them has some red and some green marbles. Remember, each of them has some red marbles and some green marbles ranging from 1 to 8 in number. Right? Ranging from 1 to 8 in number. No two persons have same number of same colored marbles. For example, if A has got 3 red marbles, then B, C, D, E, F, G, H cannot have 3 red marbles. Right? No two persons have same number of same colored marbles or same number of total marbles. If A has got a total of 7 marbles, then B, C, D, E, F, G, H cannot have a total of 7 marbles. Right? That's the idea. So these two are going to be very, very important clues. No two persons have same number of same color marbles or same number of total marbles. Now they are standing from left to right in the ascending order of total number of marbles they have. They are standing from left to right in the ascending order of the total number of marbles they have. So let's play with this. Let's see what happens. So here is some space for us to try out. See, 1, 2, 3, 4, 5, 6, 7, 8. These are the positions. And positions are also numbered. It says 1, 2, 3, 4, 5, 6, 7 and 8. Numbered from left to right. There's no significance actually. There's no point in noting it down. But yeah, 1 to 8 are the positions. A, B, C, D, E, F, G, H are the persons, let's say. Another important point is they are standing from left to right in the ascending order of the total number of marbles they have. So this person will have least number of marbles and this person here will have the most number of marbles, and accordingly it has to be arranged. Right? It's going to be in the ascending order. The total number of marbles that they have is going to be in the ascending order. Right? So maximum number of marbles will be with the 8th person. Now what is important here is to fill the number of marbles for each person. Like look at the number of clues. What kind of clues are given to us? Filphs is seated at the extreme right end of the row. Extreme right end of the row is this. This is Filphs' position. So it indicates that Filphs has got the maximum number of marbles. Right? Then the sum of marbles with Abhil and Christ is equal to the number of marbles with Filphs. So let's say A plus C is equal to F. Right? Sum of marbles with Abhil and Christ is equal to the total number of marbles with Filphs. Number of green marbles with Filphs is equal to the total number of marbles with Abhil. Number of green marbles with Filphs, FG let's say, is equal to total number of marbles with Abhi. Right? Number of green marbles with Filphs. See, only F indicates total marbles with F. FG is green marbles with F. FR would be red marbles with F. That's the convention, let's follow. So number of green marbles with Filphs is equal to total number of marbles with Abhil. Abhil has 8 marbles in total. Abhil A has got 8 marbles in total. Yeah. So I think let's also make a table here indicating number of marbles. A, B, C, D, E, F, G, H. This is, let's say, red marbles, and here is green marbles. So what do we know? Abhil has 8 marbles in total. Total of Abhil is 8, right? And since F is sitting at the extreme right end, F will have the maximum number of marbles, right? F will have the maximum number of marbles. That is for sure. Then number of red marbles with Harish is equal to the number of green marbles with Deepu. Red marbles with Harish is equal to green marbles with Deepu. Red marbles with Harish. Let's assume this is N. Number of red marbles with Harish is equal to green marbles with Deepu. This also will be N. Whatever is the value here, number of red marbles with Harish will be equal to the number of green marbles with Deepu. Right? Then Deepu has 12 marbles in total. Deepu has 12 marbles in total. So this total is going to be 12 for Deepu. Only Ezhil has equal number of green and red marbles. So he is the only person who's got equal number of green and red marbles. Other persons do not have equal number, right? Only E will have same number here. So if this is 4, this also will be 4. If this is 5, this will be 5. If this is 6, this is also going to be 6. And so on. Sum of the number of red marbles with Abhil and green marbles with Guna is equal to the total number of marbles with Filphs. Number of red marbles with Abhil. AR plus green marbles with Guna. GG is equal to total number of marbles with Filphs. Marbles with Guna is equal to total number of marbles with Filphs. Guna has 7 green marbles. Guna has got 7 green marbles, and Barun has 5 red marbles. Barun has got 5 red marbles. Alright, so I think that's the data we have. All the points have been covered already. Filphs is at the extreme right hand, we have already marked here. Sum of marbles of Abhil and Christ is equal to number of marbles of Filphs. This is also noted here. Number of green marbles with Filphs is equal to total number of marbles with Abhil, which is 8. We have noted here. Acha, by the way, green marbles with Filphs, FG is 8, right? So FG is going to be 8. This is 8. Alright. Then, yeah. Abhil has 8 marbles in total. Number of red marbles with Harish is equal to the number of green marbles with Deepu. Red with Harish is equal to green with Deepu. And so on. So I think this is the table that we have to fill first of all. Once this is done, automatically the arrangement would be obtained. Because what do we know about the arrangement? The arrangement is simple. Least to most. You're getting it? Least number of marbles to most number of marbles. So once you find out the number of marbles with each of these persons, total number of marbles with each of these persons, accordingly you can arrange them. So arrangement is a no-brainer. If you really look at it, in this case, arrangement is a no-brainer. What is important is to find out the number of marbles that each of these persons have got. It out. I think this we have already noted. So this point is already covered here. FG is 8, A is equal to 8. Total of A is 8. Now AR plus GG equals to F. So basically it means AR plus 7 is equal to F. Because GG is 7. We have already got that. GG is 7. Yeah. And A plus C equals to F. A plus C equals to F. Now remember, one point that you have to keep in mind is F is going to be maximum. F is going to be the person with maximum number of marbles. Most number of marbles. Now let's try to fill the gaps. See, let's try to find out what can the value of n be. Let's try and find out what can the value of n be. Remember, like I said, the most important condition given here is no two persons have the same number of same colored marbles. No two persons will have the same number of same colored marbles. Meaning, if F has got 8 green marbles, nobody else can have 8 green marbles. If G has got 7 green marbles, nobody else can have 7 green marbles. So what does it mean? It means that the row here, green row here, will have every digit from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8 in some order. Because repetition is not allowed. Likewise, red row, repetition is not allowed. For example, if B has got 5 red marbles, no other person can have 5 red marbles. They can have 5 green marbles, but they cannot have 5 red marbles now. A cannot be 5, C cannot be 5, D cannot be 5, E cannot be 5, F cannot be 5, G cannot be 5. Because no two persons have the same number of same color marbles. So 5 cannot come now. So which means again in the top row also we'll have numbers 1, 2, 3, 4, 5, 6, 7, 8. 8 cells, right? Total 8 cells in each row. And what are the range? What is the range you see? Each of them has some red and some green marbles ranging from 1 to 8 in number. Minimum they will have 1, maximum they can have 8. So one hidden agenda here is you have to fill 1 to 8 in the top row and 1 to 8 in the bottom row. Right? Also, same number of total marbles are not with two persons. No two persons will have same number of total marbles. Like for example, if A has got 8, nobody else can have 8 now total. If D has got 12, no other person can have a total of 12. That's what we need to keep in mind. So keeping these conditions in mind, let's try to fill the gaps. For example, what can be the value of n? See, n can be 1, 2, 3, 4, 5, 6, 7 or 8. These are the possible values of n. It cannot be anything other than that. Every number here is 1 to 8. Now, can n be equal to 7? No, because 7 is already there in this row. This is like playing Sudoku. I'm sure all those who are good at doing Sudoku or they have done Sudoku in the past, they will be able to solve it faster. N cannot be 7. N cannot be 8. And n cannot be 5. It cannot be 7, 8 or 5 because if n is 7, repetition is happening. If n is 8, again a repetition is available. N cannot be 5 because that again would be a repetition in that row. So 5, 7, 8 are ruled out. 5, 7, 8 are ruled out. Now, can n be equal to 1? N cannot be equal to 1. I'll tell you why. See, if you take n as 1, then what should be this value? It should be 11, because 1 plus 11. See, remember, total is 12. We know that total of this column is 12. So if n is 1, then this should be 11. 1 plus 11, 12. But can there be 11 marbles? No. Maximum that a value can take is 8. Maximum that a person can have of one type is 8. So if this is 1, this should be 11, which is not allowed. If this is 2, this should be 10. That also is not allowed. N cannot be 2, because if n is 2, then this should be 10. 2 plus 10, 12. But can somebody have 10 marbles? No. N cannot be 3, because if n is 3, this should be 9. 3 plus 9, 12. Can n be 4? Possible. N can be 4. If you take n as 4, then this is 8. 4 plus 8, 12, possible. So n can be 4. Now, the point is, can n be 6? N cannot be 6 as well. I'll tell you why. If you take n as 6, if this is 6, this also should be 6. Meaning D will have 6 red marbles and 6 green marbles. But we know that E is the only person who will have same number of marbles for both red and green. Yes or no? That point was given somewhere. Where was that point? Only, look at this, only Ezhil has equal number of red and green marbles. So n cannot be taken as 6, because if you take n as 6, then this also will be 6. 6 plus 6, 12, right? Then D will have same red and same green marbles, which is not allowed. Only E will have same red and same green. So n cannot be 6. The only possible value for n is 4. This is the most important part. N should be equal to 4. Yes or no? 1, 2, 3, 5, 6, 7, 8 are ruled out. N is equal to 4. This is equal to 4. Yes or no? So this also is 4. If this n is 4, remember, this is n, D green is n, and H red is also n. So both are going to be 4 and 4. D green is 4. H red is also 4. Right? Now if D green is 4, then D red should be 8. Because 4 plus 8 will make it 12. 4 plus 8 will make it 12. That's it. One point is solved. Likewise, try to fill the gaps. So basically, we are doing Sudoku in today's class, right? We are doing Sudoku. Now, what do you want to try out? See, would you like to try E? Can E be 1, 1? 1, 1 is possible. 2, 2 is possible. 3, 3 is possible. E cannot take 4 or 5 or 6 or 7 or 8. Yes or no? Try to find out the value of En. See, we know that E red is going to be equal to E green. Yes or no? E red and E green are equal. What are the possible values? 1, 2, 3, 4, 5, 6, 7, 8. Yes or no? We know that E red and E green are equal. The values are 1, 2, 3, 4, 5, 6, 7, 8. Now, can it be 8? No. Can any of these two be 8? E green cannot be 8 because 8 is already available. Can it be 7? Not possible. Can it be 4? Not possible. Can it be 5? Not possible. Because if E green is 5, E red also will be 5. And two 5s cannot be there in the same row. So 4, 5, 7, 8 are ruled out. Can it be 6? No. Because if this is 6, then this also will be 6. 6 plus 6 is 12. But two persons cannot have same number of total marbles. So it cannot be 6 also. You're able to follow? Can it be 6? If you take 6 here, this also is 6. 6 plus 6, 12. But we already have a total 12 here. So 6 is not possible. So E can either be 1 or 2 or 3. E as in not E, the E green and E red. Each one can either be 1, 1 or 2, 2 or 3, 3. So that clarity we have now. Chalo, try to work. What else can we work on? I think the other thing that we can work on. So we have got 3 possibilities for colors of E here. Let's try to find out A, because we know the total of A, right? Let's try to find out the values of A. I mean, you can try anything now, A or B or whatever. Let's try to fill B green first. Maybe that is easy. B green. C, can 1 come? 1 can come. 2 can come. 3 cannot come. I have to clear some, I have to get some space. I'm just, right, I have to, I'm just clearing whatever we have done for n here. You know what is done. And we know that E also will be 1, 2, 3. Right, remember this is going to be, I'll note it here. E red, E green, it will be either 1 or 2 or 3. These are the possibilities. Now, shall we try for B? B green. What can B green be? 1, 2, 3, 4, 5, 6, 7, 8, right? B green. Green cannot be 4, 8, 7. 4, 8, 7 not possible. Now B green cannot be 3 because 5 plus 3 will make it 8, but 8 is already available. Can B green be 4? No, 4 is already ruled out. Can B green be 5? No, B green cannot be 5 because this is already 5. B red is 5, then B green cannot be 5. Only E will be equal. Can B green be 1? Yes, it can be 1 or 2 or 6. It can be 1, 2, 6. So I'll do one thing. I'll just fill it here. 1, 2 or 6. We'll come to this later. B green can either be 1, 2 or 6. Right? Let's try to find out F red. What are the possible values of F red? 1, 2, 3, 4, 5, 6, 7, 8. F red, right? See, F red cannot be 5 or 4 or 8 because in the red we have already got 5, 8 and 4. So 5, 4, 8 is ruled out. What else? Remember, F is supposed to be the maximum. F is supposed to be the maximum. Since F is the maximum, it has to be more than 12. Total of F has to be more than 12. More than 12 means this has to be more than 4. Because if this is 4, 4 plus 8 makes it only 12. It should be more than 4. It could be 5, 6, 7, 8. Right? 5, 6, 7, 8. So 1, 2, 3 are ruled out. F red ke liye 1, 2, 3 is ruled out. Because if you take 1, then 1 plus 8 only 9, which is less than 12. 2 plus 8, 10, less than 12. 3 plus 8, 11, less than 12. 4 plus 8, anyway ruled out. So F red can be either 6 or 7. 6 or 7, right? I'm just taking up possibilities. We'll figure out. So, what else? I can say this should be either 1 or 2 or 3. No point in writing all those possibilities only. Okay, let's try for A now. What can be A? A red. Let's try out A red. Can this be 1? If this is 1, this should be 7. Are you able to follow? I'm trying to find out A red. 1, 2, 3, 4, 5, 6, 7, 8. Now, first of all, can A red be 8? No. A red cannot be 8 because total itself is 8. If this is 8, then this cannot be 0, right? 8 plus 0 is 8. So this cannot be 8. Can A red be 5 or 4? No. A red cannot be 5. A red cannot be 4 because 5, 8, 4 already there. 6, 7 I cannot consider now because 6 or 7 is a possibility. If F red is 6, then A red cannot be 6. If F red is 7, then A red cannot be 7. So 6, 7 we can't say anything now. Now can A red be 1? Try that. Can A red be 1? If A red is 1, then A green should be 7. If you take this as 1, then this should be 7. But 7 here is not allowed because we already have this 7 here. So A red cannot be 1. Can A red be 2? Yes. 2, then this should be 6. If this is 2, then this should be 6. 2, 6 is possible. 2, 6 is possible. But the problem is, if you take A red as 2, remember A red is 2, then 2 plus 7, F should be 9 only. Are you able to follow? If you take A red as 2, then 2 plus 7, F will become 9. But can F be 9? No. F cannot be 9 because F has to be more than 12. So A red cannot be 2. A red cannot be 3 also, because if you take this as 3, 3 plus 7, F will be only 10. F has to be more than 12. If you take A red as 6, 6 plus 7, 13 is possible. A red 7, 7 plus 7, 14 is also possible. If A red is 7, 7 plus this 7, 14 is possible. Yeah. So A red can be 6 or 7. If A red is 6 or 7, then this will be 2 or 1. Yes or no? 6 plus 2, 8, or 7 plus 1, 8. Yes or no? 6 plus 2 will be 8, or 7 plus 1 will be 8. So what is that concrete thing that we can take up? Oh. A plus C is F. So 8 plus what are the possible values of F, by the way, now? 6 plus 8, 14, or 7 plus 8, 15? Yes or no? 6 plus 8, 14, or 7 plus 8, 15? And if I go by this, 6 plus 7, 13, 7 plus 7. I think we have got it. I think I've got a clue here. See, if you look at, we know that F can be 6 or 7. A red can also be 6 or 7. F red is 6 or 7, A red is 6 or 7. Now try and understand. If this is 6, 6 plus 8, 14, F's total is 14, or 7 plus 8, 15, right? So F is either going to be 6 plus 8, 14, or 7 plus 8, 15. 14 or 15. That is for sure. Yes or no? F is either going to be 6 plus 8, 14, or 7 plus 8, 15. Now, what value of A red can make it 14 or 15? See, if you take A red as 6, 6 plus 7 is only 13, which is not available here. But if you take A red as 7, 7 plus 7 makes it 14. So I think taking A red as 7 will make it correct. 7 plus 7, F will become 14. F's total will become 14. 14 meaning this should be 6. 6 plus 8, 14. I hope you are able to follow what I have done here. The possible values of F red were 6 or 7. 6 plus 8 will make it 14, or 7 plus 8 will make it 15. Possible values of A red are 6 or 7. If I take this as 6, 6 plus 7 doesn't give us 14 or 15. Only 7 plus 7 gives us 14. So F is equal to 14. That is concluded. Yes or no? So now I think we can proceed further. Let me just clear up unnecessary stuff here. This is 7, this is 6, and this we have got to know it's 14. So if this is 7, this should be 1. 7 plus 8, 7 plus 1, 8. Yes or no? 7 plus 1, 8. So what is F? 14. Total of F is 14. Clear? Yeah. Now try to find out the other things. Can B green be 1 now? B green cannot be 1. It can be 2 or 6. 5 plus 2, 7, or 5 plus 6, 11. Okay, now can E red or E green be 1? No, because 1 has already come for A green, right? So E green cannot be 1. E green cannot be 1. Can it be 2 and 2? Yes. Can it be 3 and 3? Yes. 3 and 3 is 6, 2 and 2, 4. That's possible. Yeah, so I think this equation is done. A red plus 7 equals to F is done. I'm just clearing it off because since we have already used it, let me clear all the things that have already been verified. This also is verified. I think we can find out C's total now. A plus C equals to F we knew, right? So work on that. Let me clear this also. Let's have only what is possible so that it's easier to close. Okay, we know that A plus C should be equal to F. A is 8, F is 14. So C's total should be 6. C's total should be 6. Yes or no? 8 plus 6 is 14. If C is 6, see, remember, if you take ER and EG as 3 and 3, if you take ER, EG as 3 and 3, 3 plus 3 will become 6. But if this is already 6, this cannot be 6. Which means E cannot be 3. E red, E green cannot be 3. Yes or no? If you take 3, 3, then this would become 6. But since C is already 6, this cannot be 6. So E red and E green has to be 2. Closed. This is 2, this is 2, which means this total is 4. If this is 2, this cannot be 2. If E green has come out to be 2, B green cannot be 2. B green has to be 6. 5 plus 6, this is 11. Now I think we can fill up the gaps. Yeah. So you see in the bottom row we have already got 1, 2, 4, 6, 7, 8. So what is left out? 3 and 5. 3 and 5. And in the bottom row we have got 2, 4, 5, 6, 7, 8. So in the top row we need 1 and 3. Yes or no? In the top row we need 1 and 3. In the bottom row we need 3 and 5. Am I clear? Try it out. What will be the value of, let's say, H green? Can it be 1? No. Can it be 1? No. 1 is already here. Can it be 2? No. 2 is already here. Can it be 3? Yes, possible. Can it be 4? No. 4 is already available here. Can it be 5? Acha, we already know 2 values will come, right? Why are we checking all that? What are the possible values? Bottom row mein we have got 1, 2, 4, 6, 7, 8. So 3 and 5. For the bottom row, 3 and 5. So if this is 3, then this will be 5, 5, 3. Yes or no? If this is 3, then this is 5. If this is 5, then this is 3. In the top row, what do we need? I think 1 and 3. So 2, 4, 5, 6, 7, 8 is 1 and 3. 1, 3 or 3, 1. Now try. See, we know the total already. This total has to be 6. So if this is 1, this should be 5. If this is 3, then this should be 3. But can it be 3, 3? No, because only 2, 2 is, only E can have equal number of same color, equal number of marbles. C cannot have equal number of marbles of red and green. So 3, 3 is ruled out. See, either 1 plus 5 will make it 6 or 3 plus 3 will make it 6. There is no other choice. So 3, 3 is ruled out because we need the total to be 6. So 1 plus 5 is 6. If this is 5, then this cannot be 5. This has to be 3. And if this is 1, this cannot be 1. This has to be 3. Done. So 1 plus 5 is 6. This 3 plus 7 is 10. And 4 plus 3 is 7. And you can check no two totals are equal, right? We have got 8, 11, 6, 12, 4, 14, 10, 7. Now arrange them. What is the arrangement? Least to most. So what is the least number here? 4 is the least number. E comes first. After 4, the least total is 6. So C. After C, which is 6, the next one is H, 7. Then after H, we have 8, which is A. After 8, we have got 10, which is G. After 10, we have 11B. And after 11, we have got 12, which is D. So that's the arrangement. That's the final. That's the final arrangement, right? I can also list down the number of marbles they have got. E has got 4, C has got 6, H has got 7, A has got 8, G has got 10, B has got 11, D has got 12, and F has got 14 marbles. Remember the two important conditions here were, I'll just clear up whatever is scribbled here so that you can check it easily. Sudoku, basically a Sudoku case. The important conditions were no two numbers in the row should be equal. So you see 1, 2, 3, 4, 5, 6, 7, 8, all we have got. Similarly here also 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And no two totals also have to be equal. Only E can have equal number of red and green marbles, which also is satisfied. So with this, the arrangement is done.